Hello, everybody, and welcome to your linear algebra review on Gauss-Jordan elimination with one solution. My name is Jason, and I work for the ASU Tutoring Centers. Now, if you haven't seen the previous videos, I definitely recommend checking them out. We went over what Gaussian elimination was, and the goal of Gaussian elimination is to use row operations to reduce your matrix down to row echelon form, or REF. Now, Gauss-Jordan elimination, you take it a step further. So instead of just getting your system down to row echelon form, you want to get it down to reduced row echelon form, or RREF. So to get it into reduced row echelon form, you first get it into row echelon form, which, if we recall, means that the first non-zero constant in each row is a 1, that as you move down rows, that 1, that leading coefficient, gets further to the right, and that if you have any zero rows, like rows of just all zeros, those are at the bottom of your matrix. So that's what row echelon form is. Reduced row echelon form is you take it a step further, and now any leading coefficient you have, so any leading 1, it should have zeros all beneath it from the row echelon form, and then for the reduced row echelon form, it should also have zeros all above it. So that's what reduced row echelon form is. You have zeros all above those as well. Cool. So let's see it in action. I'm going to show you the thorough process to get this matrix, this first one, into row echelon or reduced row echelon form. And I am just going to show you the reduced row echelon form of this following matrix down here. Okay, I'm not actually going to get it into reduced row echelon form, but I'll show you what it looks like. So let's start with our first matrix. So first things first, you take your system of linear equations and you rewrite it as a matrix system. 1, 6, 1. Wonderful. And now our goal is to get it into reduced row echelon form. So the first goal is always to get a 1 in the top left position. Now we have a 0 here. So currently that's impossible, right? Because we can't really multiply by anything to get a 1 there. But what we can do is we can switch rows, right? That's a row operation. And in this case, if we switch the first and second row, we would now have a 1 in that top left position. So let's do that. Let's do row 1, and we're switching it with row 2. That is an allowable row operation. And now we suddenly have a 1 in that top right position. So then our next goal is to get this matrix into row echelon form, right? So typically the process for that is you get a 1 in the top left, and then you get zeros all beneath it, however many zeros there are. Then once that column is done, you move on to your next column, and your goal is to get a 1 here and zeros beneath it, and you keep repeating this process until you're done, until you've run out of rows, right? So in our case, we already have a 1 in the top left, and we already have zeros beneath it. So then we're done with the first column. We would move on to the next column. And our new goal now is to make this into a 1. Well, how do we make that into a 1? Well, we multiply that row by 1/3. So we have 1, 6, 1, 0, 1, -1. Okay, so now we have a 1 in that position. And we can't get any zeros beneath it because it's at the bottom. And so we're done. Our matrix is now in row echelon form. So then to get it into reduced row echelon form, so once you've basically finished this component of getting all those 1s and the zeros beneath them, now you can start getting zeros above them. And typically the easiest way to do that is to sort of work backwards. Starting in this column, in this last column here, you want to start developing zeros above it. And then once you're done there, you want to move on to the next column. So it's like you're working your way backwards now to get the zeros above. Okay. So in our case, right, we'll start here. We'll start in this column, and we want to get a 0 above this. So we want this to be a 0. How are we going to do that? Well, we're just going to take row 1 and subtract 6 row 2s. Because we have a positive 6 here, right? So if we want to get rid of it, we need to subtract 6 from it. So multiplying that 6 by the 1 there gives us a 6, and then we can subtract. So seeing that in action, we'd have this term minus 6 of those. So we have 1 minus 6 times 0. 6 times 0 is 0. 1 minus 0 is 1. Which is important, right? Because we needed that to stay as a 1, because it's our leading coefficient. So that's why we sort of needed to get that 0 here first. That way it doesn't end up changing it when we do the subtraction. Then we move on to our next term, the 6. So we do 6 minus 6 times 1. 6 times 1 is 6. 6 minus 6 is 0, which is what we wanted, right? That's what should have happened. Then we move on to this term. So we have 1 minus 6 times this. 6 times negative 1 is negative 6. 1 minus negative 6 is 1 plus 6, which is 7. Wonderful. And so now if we convert this matrix back into a system of equations, if we look at our first row, it tells us x1 plus 0 x2s, so we can ignore that, equals 7. And then if we look at our next row, it's saying 0 x1s, so we can ignore that, plus x2 equals negative 1. So we have our solution. We have our solution. There it is. x1 is 7, x2 is negative 1. And if we wanted to, we could write this solution as a vector, which is very common in linear algebra. So we could just basically toss the x1 and the x2 into a vector and say that that vector is equal to 7, negative 1. Now, not all matrices are going to be this nice. Not all matrix equations are going to be this nice, where you only have one solution. Some of them you'll have infinitely many solutions. Some of them you'll have no solution. And we'll be going over those in future videos to come. Okay. But in this case, we just had one unique solution, 7, negative 1. Now I'm going to clear this. So if we were to look at our next matrix, the 3, and actually what I'm going to do, I'm going to do part of the work. So we have 3, negative 8, 5 augmented with 14, 3, 2, negative 1 augmented with 24, and 1, 0, 2 augmented with 17. So this is our next system. So I'm not going to show the steps to get it into row echelon form because we've done that in previous videos. So I'll just show you what the row echelon form is. So if we did all the row operations, got it in row echelon form, it looks like this. It looks like 1, 0, 2 augmented with 17. It looks like 0, 1, negative 7 halves augmented with negative 27 halves. And then 0, 0, 1 augmented with 5. So this is what the row echelon form of the matrix looks like, okay? And again, if you want to see how to get a matrix in row echelon form, check out the previous videos. Now from here, I'm gonna show you the steps to get it into reduced row echelon form. So as I mentioned before, we sort of have already the ones with the zeros under them, and now our goal is to start developing zeros above them. And to do that, we typically work backwards. So we'll start with this column now, and we want to get zeros in these positions. Okay, so let's start with the second row. I can do row 2 plus 7 halves times row 3. Right? Because if we look at this column, 7 halves times 1 gives us positive 7 halves, and then adding that to the negative 7 halves in row 2 gives us that 0. Okay, so this is the operation we're going to use. And in doing so, the first row is unaffected. The second row is the third row is unaffected, rather, my bad. And the second row, what's going to happen is you're going to have 0 plus 7 halves times 0, which is just going to stay as 0. We're going to have 1 plus 7 halves times 0, which is going to stay as 1. We're going to have negative 7 halves plus 7 halves times 1, which is going to give us the 0 that we wanted. And then we're going to have negative 27 halves plus 7 halves times 5. 7 halves times 5 is 35 halves. 35 minus 35 minus 27 is 8. So we end up getting 8 halves, which is 4. And then our last step is to get a 0 in this position here. And what that'll look like will be row 1 minus 2 row 3s. And after doing so, we end up getting a 7 there. Okay, end up getting a 7 there. Cool. So this is our matrix in reduced row echelon form. So this is in reduced row echelon form. And then just reading off this row and then this row and then this row, we get that our solution, or rather, sorry, we're not using x1, x2, and x3, we're using x, y, and z, right? Remember, the variables chosen are completely arbitrary, but once you choose your variables, you should use them consistently throughout. So our solution ends up being 7, 4, 5. That's our solution to this second system. Wonderful. Well, thank you for watching. Let me go ahead and tab over to this next slide. So as I mentioned at the beginning, I work with the ASU Tutoring Centers. So if you want more information about the free services we provide to all 4 campuses and online, please check out tutoring.asu.edu. If you want more content like this that specifically goes over concepts in your course, or if you want to see what upcoming review sessions we have for the exams in your course, please check out this link down there. Wonderful. Thank you again and have a wonderful day.